Hey guys, welcome to the third section of my Java game development tutorial series. For those of you who are new, my name is Ryan Bishop, and in this tutorial we move on from the 2D realm into the 3D. Now if this seems overwhelming to you, don't worry. 3D development is a very difficult concept to grasp, and the implementation of the fundamentals such as 3D transformations and rendering varies greatly from one API to another. So without further ado, let's begin. So for this tutorial, I will be using the Java3D API. Now there is some speculation as to whether or not this API is good for game development, as it uses a scene graph system. Now what this means is everything exists as part of a hierarchy. Now if you're familiar with tree data structures, essentially that's what's going on here, but I'll get into that more as we go along. It's also important to note that Java3D requires a separate download from the JDK. Now, the Java3D API is available through Oracle's website, and I'll include a link in the description. The most recent version as of this video's record date is 1.5.1, and the installation comes in the form of an executable that will guide you through installation. So once you have the API downloaded, you'll want to include the jar files in your project. Now, jar is short for Java Archive, which is similar to a zipped file. The jar files are what contain all the class files needed for you to reference the API, similar to DLLs. Now I'll be using NetBeans for this tutorial, and to add the files to your project, you'll want to click the Libraries folder in your project directory, and click on Add Jar/Folder. In the pop-up file browser, navigate to the directory where you installed Java3D, and navigate to the ext folder. In here, select the 3 jar files, and click Open. And there you go. You've now added all the Java3D class files to your project. So in this tutorial, I'll just be touching on some of the basics of Java3D, enough that you can get into it and play around if you're so inclined. Now the most basic Java3D programs implement what is known as a virtual universe, and it uses a class called SimpleUniverse for the task. This is going to be the basis of all Java3D programs and is the root node of the entire scene graph. You can think of this as our own universe before the point of creation. It's basically an empty world in which we will add our object hierarchies. And we achieve this through the branch group node. The branch group object is the child node of the universe, and the universe can have multiple branch groups, but this will be the root of everything in our world. And here's a basic diagram of a scene graph showing the hierarchy of a basic universe. Now this is about as simple as a scene graph gets, so let's explore how to expand this hierarchy to create a 3D world. Now it's perfectly okay to have a simple scene made up of simple geometric shapes, but that's pretty boring, isn't it? So the first thing we'll focus on is lighting. Lighting adds depth and really makes our 3D world pop. Now there are several types of lights you can have in your scene, but we're only going to use 2 of them, directional and ambient. Directional lights, as the name implies, shines light in a specific direction, while ambient light is more like a point light in the sense that it floods our scene with light from no particular direction. This is very simple, and since the directional light contains all the components that an ambient light does, I'll explain the directional light. Now to create a directional light, we need 3 parameters. We need a sphere of influence, we need a color for the light, and we also need a direction. So here's an abstraction of what the light looks like in the context of the branch group. The color determines what color of light will be shined on objects within the sphere of influence. Anything outside the sphere will not receive light, and the direction determines how the objects within the sphere will be shaded. And here's how this is set up in the scene graph. As you can see, the light is treated as a separate object from the geometry, but as part of the same branch group hierarchy. Now that we've shed some light on our scene, let's learn about transformations. Now if you're familiar with matrix transformations, I've got some good news for you. Transformations in Java3D wrap this functionality, making transforms much easier. A few things you should know about Java3D is it uses a right-hand coordinate system, which simply means the positive z-axis extends towards the screen, rather than away. Also, units are measured in meters, but that's fairly irrelevant unless you're creating 3D models. Now, like everything else, transforms are part of the scene graph hierarchy. While transforms are easier to perform, they are done in a somewhat different fashion. All transforms such as translation, scaling, and rotation are applied to a transform 3D object, which is most likely where matrix math is calculated. This object is then applied to a transform group, which, when dealing with transforms, becomes the parent node for any objects that should apply the transformation. The branch group becomes the parent for the transform group and any objects that don't require transformations from the origin. Here's a representation of the transform scene graph hierarchy. As you can see, the geometry is no longer a direct child of the branch group, but rather the transform group. Now a step up from the basic lighting is a more advanced system for rendering, and that's the appearance class. The appearance hierarchy is a child of the geometry in a scene. Therefore, each shape or model can have its own hierarchy of appearance to any level of complexity. There are 5 basic parameters to the appearance hierarchy, and they include material, which governs how an object reflects light, transparency, color and texture attributes, and the texturing itself. And as we'll see in one example, using textures on primitives requires flags to be set for texture coordinates and normals. Here's a basic scene graph that illustrates the different parameters that can be set. These can be used in many combinations to create custom effects, especially when paired with lighting. Now a few notes. If you are familiar with editing materials in a program like 3ds Max, the material parameter is similar here. You can set ambient, emissive, diffuse, and specular colors, as well as the level of shininess. Also, the texture parameter requires a texture loader object to pull in a texture from a file, and can be set to display RGB color or luminance, which is black and white, similar to a height map. You can also set how the textures tile and boundary color. Now that we've learned all the ways we can modify objects in our universe, let's talk about ways of displaying our universe. The great thing about Java3D is that we don't have to set a canvas for drawing our universe. If one is not specified, the universe creates one automatically. However, if we want to customize the displaying of our world, we need to create a 3D canvas. The canvas can be displayed within an applet or JFrame, which is then contained in a main frame, as Java3D does not really play nicely with lightweight components such as the swing library. In the creation of our application, we follow a certain process. First, we construct the main applet class. During the applet's creation, we construct the 3D canvas using the preferred graphics configuration of the universe. We then add the canvas to the applet, construct the universe, and pass it the canvas to use as the display context. Once the universe is constructed, we add our branch group hierarchies, and finally the mainframe is constructed, and is passed the applet to display. And here's an abstraction of that structure. You can see how highly detailed the structure of our 3D world is in the Java3D API. So if you've hung on this long, I commend you. Now comes the fun part, the code. I've created sections for each of the topics discussed. Then we'll take a look at a simple program that implements it all to form a simple bouncy ball simulator. Now this code is based on the basic tutorials from the Java3D website, and I'll include a link to download the projects. So feel free to download and play around with them. So without any further ado, let's explore the code. So here we have the main project for our 3D demo, and this contains all the lessons that were explained in the tutorial, or in the PowerPoint rather. So here's our basic world. Here we just set up the simple universe, and remember this is going to contain everything in the branch group, basically everything in the world. So we create our branch group, which will contain all our geometry, lighting, and so on. And this is really all we're going to add. We're going to actually add a color cube to that, which is going to be our geometry for this basic tutorial. And then we set the viewing platform for the universe. This is like setting the view matrix in something like XNA. And then we add our branch group to the universe. And when we come down here, we're going to create a new world. Now I've set this up so that we have one main method for all of the classes. That way I can uncomment whichever section we're on at the time and view that part of the tutorial. So right here, if I run this now, it doesn't look like very much. It just looks like a red square in 2D space. Now this is because of the way the cube is placed in the world, and it's also because there's no lighting attached to that. So next thing we're going to look at is the lighting. So this is the second part of the tutorial. And here you can see that there is specular and diffuse shading on this sphere. So let's look at the code for that. Again, creating the simple universe to contain all our objects. We're creating the branch group, and we're creating a sphere here. Then we're going to add our sphere to the branch group. We're going to create a light. Now this is going to be the, I'm sorry, not a light. We're going to create a color for the light. We're going to create the sphere of the sphere of influence, which will determine how much influence our light has. We're going to create the direction for our light, because we're going to be creating a directional light. Then we're going to actually create the directional light. Now this takes two parameters. This takes the color of the light, and it takes the direction that it's shining in. And then we use another method called set influencing bounds to set the sphere of influence for our light. We're then going to add the light to the group, the branch group, and we're going to again set the viewing platform of the universe, and we're going to add our branch group to it. And as you saw, this is what you get. Now next, the next part has to do with transformations. And what we're doing in this tutorial is basically we're setting different shapes along each axis, and we're incrementing by 0.1 each time. So we're creating, basically along the x, we're creating a sphere every 0.1 meters. Along the y, we're creating cones, and along the z, we're creating cylinders. Now you can't really see because of the viewing platform, and I never really got into how to transform the view, but we'll save that for a different tutorial. So in this code, again, we're setting up our simple universe, our branch group. You're going to find that this is common throughout all of our Java 3D work. We're coming into a for loop here. For all the x's between -1 and 1, we're going to increment 0.1, create a new sphere, create a transformation group. Remember I talked about that. All the transforms are going to be applied to that transformation group, and then every object we put into that transformation group is going to be transformed by the transform we set here. And what we're going to do for this is we're going to set the position to x, which as we go through the incrementation, it's going to go up 0.1 each time. We're going to set the transform to that translation, that position, that vector. We're going to set the transform group's transform. We're going to add the sphere. Now remember, when we add this to the transform group, it's going to be transformed wherever that x position is, because we set the transform here, and then we set it to the transform group. Then we're going to add the child to our main group, which is the branch group. And we're going to do the same thing for the y using cones, and the z for cylinders. Then we create our light down here the same way we did in the last tutorial, and this is the result. Now I'm running a little short on time, so I'm going to cut the video off here. And when we come back, we're going to look at the display effects tutorial and the canvas demo, and then we're going to look at a project that brings it all together for the bouncy ball. So stay tuned for part 2.